Hello and welcome to my video. It's a pleasure for me to have you here. A few days ago I was in the woods called the Harz. It's an area in Germany and most of it is protected as a nature reserve. To walk through, spending time in it is relaxing, and this time I went to a small lake, choosing this place for my recordings. It will join me on two journeys, one to the woods and one into the world of web components. In recent years, the interest and use of web components in the community have increased significantly. Most front-end frameworks adopt the web component standard, and many developers have started using the norm when creating their widgets. Not to mention that it is now natively supported by all modern browsers. How to use the interoperability and flexibility of web components as Java developers on the server side. This video shows the use of pure client-side web components using Java or Kotlin on the server side. With the usage of different technologies in one stack and the increasing convenience for you as a developer, the security part is more important as it was ever. But how to get the overview about the full impact graph based on the known vulnerabilities? How to check all transitive dependencies against compliance issues, and how to do this as early as possible, even inside your private open source project. We will have a look at the tech stack, how it looks like for you as a server-side developer, and how to harden against known vulnerabilities for free. All tools and components I will show you are open source or free to use. After this presentation, you will be able to follow up all steps and you are ready to go. See you at my talk at DevNexus. What are web components? During the long history of developing web apps, different companies try to establish some standards. These standards are just products they wanted to push to the market and hoped that other companies will adopt this technology. This never really took off. And then during the last few years, we had finally the chance to have something like a compromise between different companies, and they defined the standard web components. Web components are based on technologies that are more or less used during the web development phase over the last 10 years already, but they define some standards, how they are communicating, how they are encapsulated. The base technologies here are JavaScript, CSS, and HTML5. Under webcomponents.org you will find a lot more information about the standards, the history, and available components. And the main thing here is that we want to have some components like we know from Swing or other UI technologies, that if I need a button, I just go to this library, grab a button, and I'm sure that this button will work with all my other components. So what we have on the client side is HTML5, JavaScript, and CSS. And the main thing is that web components are just defined for the client side. We have no communication or no access from the server side per default. So this is something, if we want to have, then we have to do it by ourselves. In this talk I want to show you how to map now this SAP UI5 web components to the server side. Why I'm choosing SAP UI5 web components. First of all, they're open source and they're available on GitHub. So go to the organization SAP and then check out the project UI5 web components. These web components are 100% web components, so they are really following the standard, or mostly they are focusing on business apps. So you have trees, you have buttons, you have sliders, you have timelines, and so on. So it's a very rich component library you can use for your tool sets. Maybe you have already customers that are using SAP somehow, and then it's good that you can fit in. But this is just an example, and you can do it with all other pure web components as well. Okay, next thing is how to use web components. First of all, you need something like a package manager. So here I'm using npm, and npm is then connecting to a main repository, and then you can grab this web component to your local machine. So this is the first thing you need to know, and for this you normally have something like an install statement. It's called npm install, and then the web component you want to have. In our case it's add UI5 and then /web components. The next thing what you need is something like an install. So if you have this component already locally on your machine, the next step would be something like how to use it inside your web page you're creating. It's like an import statement, you know, from Java or other languages. So if you want to have, for example, the badge itself, then you need inside your HTML page something like an import and then the full qualified name of this web component. For example, something like add UI5 / and then web component / dist / badge. This is a badge web component. You will find inside the repositories at SAP UI5 or at the website about the SAP UI5 web components the addresses you need to address dedicated web components. And the last thing you need if you want to use it inside a web page is the usage of the tag. So with the npm command you are grabbing this web component to your machine, so that's available for the development. Then with import you're addressing it inside your site, and then you have a dedicated tag, and here it's, for example, the tag UI5 - badge, and then you can use this component inside your HTML as a regular tag. So that's it. And the main thing is we don't want to have a pure client side. I want to show you now how to map this stuff to the server side so that you can write something like new UI5 badge, and then you will have a corresponding client-side web component used. So after we saw how to use normally web components, the next thing is how we can map this one. First of all, I'm using a framework that is doing more or less a basic work for this, and it's called Vaadin. Vaadin is an open source framework, and it's based on web components since the version 10. And what they're doing is exactly what we need. They have these web components and they have this communication layer. This is communicating to the server side, and on the server side there has a representation. For example, for button they have something like new button, and this instance you can use to interact with the client-side version. So this is existing, but I want to show you how to map generic or all the web components you want, and maybe you don't want to use the Vaadin web components. But we can use a framework, so it's open source and available on Apache license. It means we can go inside, and there is this API internally, because they are doing exactly the same what we need. They have an abstraction layer that will give you the possibility to connect with every web component. So for this, the first thing is this npm install. How to grab this one is done by a annotation. This annotation is called npm package, and the value is the web component, the address that you use, exactly the same during the npm install command, and then you have to declare the version as well. And with this, during the compile and the provisioning process, they will grab the web component from the registry and provide it locally. The next thing is you want to have it in some dedicated page. So remember this import statement, and here we have a corresponding annotation as well. So it's add JS module, and then you're using exactly the same command. Instead of import in the full qualified name, you're using now this add JS module and then the full qualified name. After this one, you have to map the Java instance with this HTML tag. So remember the HTML tag for this badge was UI5 - badge. And to make this mapping to the Java class, you need add tag as annotation, and then inside exactly the same name, UI5 - badge. How to use this one? You're creating a class and extending from component. This component is a generic web component on the Java side, and then you're adding all the three annotations, and that's it. The next thing is how to set and add properties, get properties, add properties, and so on. You have inside this component class a generic method getElement. This will give you an internal generic representation from an element, whatever it is. And then you have this method, for example, setProperty, and you need two params. One is a property name, and the second one is the value itself. That's it. And the same you're doing with getProperty. So getElement, getProperty, and then the name of the property itself. That's it. So with this, we can now set and get attributes and properties of every web component if it's following the standard. And the next question would be how to deal with complex attributes or how to deal with a component tree. So far, we are just modifying the web component attributes itself. But what we achieved so far is we have a Java class, and we can use getter and setter to manipulate the state of this web component. The whole communication from the Java side to the web component is done by the Vaadin framework. Internally, they're using the Atmosphere framework for things like long polling, firewalls, routers, and so on. Yeah, but you don't have to worry about this one because we are just on the Java side now. Okay, next thing is how to map complex attributes. Okay, next thing is how to map complex attributes or how to build a tree out of this web components. And this is very easy because the basic work is already done. So if you have a complex child, for example, an UI5 icon or another component, then do exactly the same what we have done with a badge. So create a class, extends from component, add this tree annotation, that's it. And if you want to use it inside another web component, what you should do is, instead of setProperty and getProperty, what you need is a method addChild. So you have inside your method this getElement to have this generic representation, and then you're calling the method addChild. And what you're doing is you're giving to this method the getElement result from your other mapped component. So what you're doing, if you want to have an icon, the same thing as getElement addChild, and the input for addChild is from the UI5 icon dot getElement. That's it. Now you can build complex trees of web components, and they are all synced to the client side. This is quite convenient. Okay, we want to test this now. So pure web components are just client side. It means you have for this normally JavaScript based test tools. If you want to have the convenience of the Java tool stack, and we are anyway mapping this to the server side, then we can use, for example, JUnit 5 to test this one. What we normally need for full stack test is ramping up a servlet container, for example, so that the web app is available. Then with Selenium, we are communicating with the browser. This browser is consuming the web app, so it's invoking a button, is setting a text field, and so on. And the test definition is done inside JUnit 5, so that we can deal with assertions and all this stuff. So yeah, this is quite complex. There is a tool available, and this we want to have a look at now. Okay, we know what we need for testing a web component. So what products or projects are available? So from Vaadin itself, there is a commercial project available. It's called TestBench. Why mentioning it? It's open source. So what you could do is you could have a look inside and learn how to do something like this for yourself. So what they're doing, they are connecting to Selenium, and this API, the Selenium API, will give you some generic element. And what they are doing is they are creating a TestBench element. This is the class you should inherit from. And then you have something like setProperty, getProperty, and all this stuff in this TestBench element already. So what you need to do is you are ramping up your servlet container, you are instantiating a WebDriver, and then you can navigate over this WebDriver to your web component. So the way is the same as they have done with the pure web components, but now they are connecting to the element from Selenium, but it's a commercial one. So there's a few things I want to highlight here. So the first thing is if you really need a full stack test of this web application, then you have to do all this overhead. So ramping up the servlet container, whatever it's delivering your web page, managing the Selenium nodes, dealing with web drivers, and so on and so on. This is a full stack test. This is good. But on the other side, don't test the technique you're using, so test your use cases. So this is why I'm not sure if you really need this full stack test at this point. If you want to have an open source solution, have a look at this TestBench implementation and think how they have done this mapping and re-implement it on your own way. That's one thing. But why I'm not so happy with TestBench. So TestBench itself, it's good. It was very good years ago, but it's not getting attention from Vaadin anymore. So there's no development, there's no roadmap, there are no new features, nothing. So I think this is more or less something what they're using, what they're keeping alive, but they are not really developing. So for this we need other solutions, and I have the solution that could help you if you don't want to have a full stack test. Okay, there's one open source tool that is giving you the possibility to write tests in J105. So for this, you have to go to the KaribuDSL, and KaribuDSL is DSL on top of the Vaadin components, and it's maintained by one of the Vaadin employees. So this is completely written in Kotlin, and the main thing here is that you have this type-safe builder API on top of it. So the syntactical stuff is quite nice, but if you don't want to use this one, you can just use, for example, the testing part as well. And for this, you have the test API or this test kit here inside this KaribuDSL project. You just have to add the dependency, and what you're doing here is browserless testing. Browserless testing means that you're not ramping up the whole servlet container, but you are mocking the essential parts of this one. So it's working with the Vaadin flow components, and if you're mapping your components on top of it, it's working as well. So what's going on here? So you mock up the servlet container. There are some utility methods already in this project available, and then you're just writing a test on the Java side, and then you're ramping down the mock as well. So this is very fast because you have you don't have to ramp up the servlet container, you don't have to ramp up Selenium, you don't have to deal with web drivers. It's very easy to implement because a lot of this stack is just not used by this test. And here the approach is that you're not doing a full stack test. Here the approach is that you're just testing your use cases you're using. So if you want to have a button that is calculating something after some input is done into text fields, then you can test exactly this one. What you're not testing with this approach is a communication to the client-side web component. So you just trust that this is done well and the communication is done. What you're not doing with this test is this pixel test if the layout is correct or whatever. So if you really want to have this layout test, then you should go over full stack test, but I think the most of you want to have a test for the use cases. And for this, check out this KaribuDSL. It's under MIT license and available on GitHub. We can now map client-side web components to the Java world so that a batch is just like a new batch. There's a possibility to test them in a full stack test, or we can just use browserless testing. The next thing is how secure it is or how to deal with vulnerabilities. So for this I have two things I want to highlight first. The first one is make, and the second one is buy. So make or buy is mostly the decision. So you have always the choice between make, so doing something by yourself, and the other thing is you have the choice to buy something, and buy in this session is the term for adding a dependency. make or buy. And so let's have a look at the whole tech stack. So for example, if you're choosing something like cloud native, we have something like the application, then we have the operating system layer. After the operating system layer, we are wrapping it in Docker, and last but not least, it's running somewhere in a Kubernetes cluster. So with all these layers, we are adding more and more complexity, and I want to have here just a short view about the make and buy if you're comparing them. So in an application, you have mostly more make than in all other layers, because you're coding something. And even there in this layer, I assume that in most projects you have 80 or 90% dependencies compared to your own written source code. It's the same with the operating system layer. You're adding some configurations, that's it, and the rest is the operating system layer itself, so as a dependency. So you're not writing a kernel driver. Same with Docker, you are writing a Docker file, and the first thing what you're writing is a from statement, so you're starting even there with dependencies, and in Kubernetes you are writing Helm charts. So whatever you're looking at, it's more or less, we are adding more stuff than doing by ourselves, and so dependencies are the most dominant part here. Altogether means if you're dealing more with dependencies, we have two questions to give an answer. The first one is, do we have some challenges with compliance? And the second one is, do we have something around the topic vulnerabilities? So looking at both, you will see that the compliance part is more or less one effort thing. So some lawyers will decide what's a good license you can use and what's not allowed, and then the machine can just scan all dependencies, and if there's a break somehow, so there is a wrong license somewhere in the transitive dependencies, then the machine will say to you, and you have immediately to remove it or to find an equivalent or whatever. With vulnerabilities, it's a little bit different. The vulnerabilities, you don't need a lawyer at the beginning, but the machine will scan immediately all binaries and then will let you know so how many vulnerabilities you have inside this. And now the human is the question, so or the human is now in duty, means you have to decide if this is a high risk, if this is a low risk, will this be critical for your business, yes, no, and what to do. So changing dependencies. So this is more or less what you can do. And checking at both of these vulnerabilities and compliance issues, we have different behavior. So these compliance issues are more or less like single dots. So you have here compliance issue, there a compliance issue, that's it. With vulnerabilities, it's much more beast. So you have in every layer some vulnerabilities, talking about the shift left term, so start in the beginning and try to avoid as soon as possible vulnerabilities. But over all layers you have a bunch of vulnerabilities and they can be combined. So that means more or less 2 or 3 not so critical vulnerabilities can be in some critical attack vector for your system. And not only the sum of vulnerabilities is critical, because the combination of all vulnerabilities, this is a beast, because you have way more attack vectors than vulnerabilities. Okay, it's good that we are able to scan for vulnerabilities, but there is one question: how fast we can get this vulnerability information. So the main thing here is that if vulnerability is found, you have this time until this vulnerability is public available, this information is public available. We have no way to influence this one. But until it's public available to you, it's consumable to you, you can influence somehow this time. Mostly it's part of subscribing some service that is aggregating a bunch of different vulnerability databases for you. But from the point that this information is available for you and you can consume it until it's running in production, so we're talking about time to market, This is exactly what you can influence. So you can speed up your CI environment and. But the safety build at this point is your test coverage. You need a very good test coverage because then dependency management, you can go up and down with the versions, let the test suite run, and you are safe that everything is okay. So for this there is a need for strong test coverage, and one test coverage I really appreciate at this point is mutation test coverage. If you want to know more about mutation test coverage in general, about how to use it in Java and Kotlin, check out my YouTube channel. I have there a video about mutation testing. But whatever test coverage you're using, a good test coverage is your safety build. And yeah, that's it. The most important thing after test coverage is you need a tool that is able to understand all corresponding repositories, or repository types, because with this one you have the full impact graph. So if you just have a tool for Debian repositories and you have a tool for Docker repositories and the next one for Maven repositories, then you never have the full impact graph. So you need something like Artifactory that is giving you the possibility to manage all repositories in one place, in one logical place. And then if you're identifying vulnerabilities in some of these parts, in this jar there is a vulnerability, it's used in this web archive. This web archive is part of this Docker layer, and this Docker layer is in this Docker image, and this one is used in this Helm chart. So that's it. So you need something that will give you the information about the full dependency graph and the full impact graph. Okay, we know that we need something that's able to understand all package manager to have a full impact graph and the knowledge at what place the vulnerabilities are. So for this you can use Artifactory and X-Ray. So we have a free tier so that you can try it immediately. If you want to know how to activate a free tier, check out my YouTube channel. There is an how-to about what you need and how long it takes. I think it's 5 minutes or so, and then you have a free tier instance for yourself. So, and you have two parts inside this. You have Artifactory and you have X-Ray. So Artifactory is a repository or the binary manager, and then create inside Artifactory, for example, Maven repository, Docker repository, whatever repository you need, and connect it with your project. If you want to know how to create a repository, check out the how-tos. It's just going there, say, I want to have a repository of type Maven, giving it the name and connecting to some remote instance, for example. So if you have now all these repositories and you're connecting your project to Artifactory so that you're grabbing all dependencies, the next step would be checking for vulnerabilities. We have 3 ways to check for vulnerabilities. The most detailed one is that you're going to the web UI and creating policies and rules to define what you want to detect and what you want to do if you find something, and then you're connecting watches to this one. Then you have a full detailed information or report what's going on. If you want to have an ad hoc report, so I just want to have no snapshot from this repository what's inside, you can go through the vulnerability report. But there is one thing that will help you immediately if you are just typing the first line of code in your proof of concept, for example, inside your IDE, and this is an IDE plugin. So the fastest way to get the first information is inside your IDE. So we have this IDE plugin, and this is available for IntelliJ, Eclipse, VS Code, whatever. It's open source. So if you have some feature requests, for example, just fork it, make something, change it, and give a merge request. Or if you have an issue with this, just create an issue on GitHub. What you can do is just you're adding a dependency, and if you adding this dependency, you have more or less the information already if there is something inside this dependency or inside this transitive dependencies. So, and this is done inside the IDE. I will show it to you right now, because now I will drink a coffee, then I will start packing my stuff together. It's time to leave the forest soon. So relax, I will show you what's happening inside the IDE. Okay, now we have a short view to the X-Ray IDE plugin. I just added in my Pullman dependency, so this is a Vaadin version. It's a little bit older one, so that we can guarantee see some issues. So what you will have in the IDE plugin here some kind of window. I'm using IntelliJ, so could look a little bit different on Eclipse or whatever. Then you will see the dependency we added here already. Here this 4120, 4120, and then you have the whole dependency tree, and you see there is a security issue with Jackson data binding. What you get is ranking, if it is a high, medium, or low security risk. You will see the license information, what type, version, and so on. The good thing is you can see here all detailed information. For example, if there is already a fixed version available, and what tiny summary of the issue itself. One cool thing is if you are somewhere, then you can just go here and say show in project descriptor. Then you're jumping here back to this one. And the good thing is if you decide to exclude, you can just go here and say exclude dependency. What you will get is dependency exclusion. That's it. The only thing I want to show you is how to install it. So in IntelliJ it's quite easy. You're going to the plugin, you're searching for JFrog plugin, updating it or just installing it. In IntelliJ you have to do a restart. In Eclipse could be different. And then the only thing you have to do is you're going to the settings of this X-Ray plugin, adding your coordinates, and then you can just connect your IntelliJ to the X-Ray installation. That's it. Have fun. Okay, time for the conclusion. What we saw so far. We saw how to map web components to the server side with Java. So you don't have to deal with NPM anyway. You can just create a new button and then you have a button on the screen. This is quite convenient, but how to test it? I showed you the way with the full stack test, and my preferred one is browserless testing with KaribuDSL testing. So this is the browserless testing. It's very fast. It's testing your use case, but not the full use, the full stack. On the other side, if you're adding one layer after another, it's mostly good advice to have a view on the vulnerabilities. For this, I showed you the FreeTier. Check out my YouTube channel if you want to know how to activate this one. And then you can create all these repositories, connect X-Ray to it, and then you have an overview of the full input graph about all vulnerabilities that I know. So that's good. So that's on my side. I will now go out of the forest because soonish, a little bit dark. And then I would really like to see you as my new subscriber on my YouTube channel. So if you like this auto style and want to see more about Java, Kotlin, DevSecOps, then my YouTube channels are just right for you. I have them in German and I have them in English. So then I would say have a nice day and see you on my channel.